So hello everyone, welcome to another particular course. So in this particular course, we are talking about reagent chemistry in details. So in our previous courses, we are actually covered about the stereochemistry and protection reproduction group and radical chemistry. So now we are moving to our next important chapter. This is reagent chemistry, and this particular chapter is very important for exam point of view, as well as if you want to learn organic chemistry, then you have to learn reagent chemistry in details, because the reagent chemistry, I believe that it will be the key backbone of organic synthesis pathway. Okay, so this particular reagent chemistry part will be very much big, like so many lectures will be there. So basically, I have briefly categorized this particular reagent chemistry with this particular four different segments. So in our first segment, we are talking about the basics that you have to know about the particular before starting the reagent chemistry. So first we are talking about the introduction of reagent, like what is reagent and how the reagent is different with catalysis. Okay, then we'll learn about the oxidation and reduction. What is mean by oxidation and reduction in terms of organic chemistry point of view, as well as we are discussing about the how to calculate oxidation and reduction of a particular group or particular center. Okay, like in the case of aldehyde acid, what is the oxidation number of the carbon center? We'll discuss about this. And later we are talking about the selectivity of organic reaction, because learning selectivity is very important, because some of the reagents are there which actually work with certain functional group, keeping the other functional group intact. So you have to learn about the various stereochemistry associated with the reagent chemistry part, like regioselectivity, chemoselectivity. So with this, we have to end the basics. Next, we are talking about the reduction part first. Reduction part first, we are talking about the different reducing agents, such as the nucleophilic reducing agent, and the electrophilic reducing agent. Then we are talking about the solvated metal ion mediated reduction, and then talking about the hydrogenation. And till here, I think it will be enough for the examination that we are targeting for, like IITJAM, CSIR, NET, and GATE examination. Okay, we have end our discussion regarding reduction here. Then we are move on to the organometallic reagents. Organometallic reagent, mainly we are limited with the Grignard reagent, Gilman reagents, and organolithium based reagents. Then we actually shifted our focus to the oxidation. Oxidation, there is a mainly four broad classification is there. One is the chromium based reagents, one is the manganese based reagent, one is the DMSO based reagent, and there are some organic reagents are there which actually used in the oxidation, such as hypervalent iodine mediated oxidating agent. Then we can say about the tempo mediated oxidation. So this is the organic based reagent. So with this we have to wrap up our reagent chemistry classes, and it will be a very vast lecture, like so many lectures are there. So have faith, we will complete with accordingly. Okay, so with this we have to enter in our first particular lecture, that is the introduction of reagent. First, let us understand that what is the reagent. A reagent is a substance or compound that actually added stoichiometry to a system which cause a chemical reaction to occur. Now, I have highlighted this particular term stoichiometry because this term actually differ a reagent and a catalysis. Okay, so let us understand that what is the basic difference between a reagent and catalysis, because sometimes we often confuse about the reagent, what is the reagent and what is the catalysis. So I hope that this particular comparison will clear out all your doubts. Okay, so difference between reagent and catalysis. First and the foremost difference between a reagent and catalysis is reagent use stoichiometric amount. Like stoichiometric amount means, like if you use your substituent 1 molar or 1 millimolar amount, then your reagent will be either 1 millimole or 0.8 millimole, or a little bit of excess, it is a 1.2 millimole, vice versa. But in the case of catalysis, we use in catalytic amount. Like if your substrate use in a 1 millimolar use in a 1 millimolar ratio, then your catalysis may be a 0.001 millimolar ratio. So this is the foremost difference between a reagent and a catalysis. Also, there is another important difference between a reagent and catalysis is a reagent completely consumed in a reaction. That means reagent, some part of the reagent will actually attach with the substituent to get our product. That means reagent cannot be recoverable. But in the case of catalysis, what happened that it drives the reaction, or you can say that it drives the kinetics of the reaction. Like it helps to do the reaction with a lower activation energy, or we can say that catalysis will help the reaction to go fast. Maybe sometime in the case of negative catalysis, or the reaction rate will decrease, but the catalysis can alter the reaction rate, but at the end of the reaction catalysis will, we can actually recover the particular catalysis from the reaction mixture. Okay. So here also third point, catalysis can alter the reaction rate, but reagent doesn't have any role in reaction kinetics that I already discussed. And reagent actively participate in the catalysis, where catalysis partially participate in the reaction. When I will teach about the asymmetric synthesis part, there you can find that some kind of bifunctional catalysis or some kind of proline mediated catalysis, they are actually help to stabilize the transition state by doing some kind of hydrogen bonding or some kind of other non van der Waals interaction and some kind of other interaction. It can stabilize the transition state, and by stabilizing the transition state, what happened that the particular reaction kinetics or the activation energy of moving the reaction towards the product side is goes down, and due to this particular phenomena, the reaction kinetics were altered. Okay, and that's why, and after the stabilizing the energy of the particular transition state, the catalysis removed the particular system, and we got our product back. So catalysis doesn't present in the final product. It will actually attach the particular substrate in situ manner, and then it will remove after his job is done, and the job of the catalysis is simply alter the reaction kinetics. So I hope that this uh, will be enough for understanding that what is the difference between a reagent and catalysis. Now we move our next segment, that is the oxidation and reduction of functional group. So inorganic term, you can say that the broader definition of oxidation and reduction are referred to the loss of electron and gain of electron. Like oxidation suggests that your compound had lost some kind of electrons, some number of electrons, and the reduction specifies that your compound gained some kind of electron from either external medium or by doing some kind of reaction. Okay, or we can say that oxidation leads to the increase in oxidation number, and in the case of reduction, it decrease the oxidation number. Now it will be a little bit confusion about the oxidation and oxidation number, but we can understand that if a particular compound lose some kind of electron, then we can say this is oxidized or oxidation happens. And if any compound gains some kind of electrons, then we can say the reduction happens. Now, when it will be in the organic chemistry point of view, it is a little bit of change. Like in the case of organic chemistry, if any compound has gained oxygen, then we can say it is an oxidation. And also if the compound lose hydrogen, then it is also called an oxidation. Okay, so in practice, a series of functional group has been quantitatively identified in the order of increasing oxidation strength. So thus oxidation is referred to as the conversion of one functional group higher in the sequence of another lower functional group. Okay, so this particular segment I will explain with the example, but give me some more time to discuss about the reduction part in terms of organic chemistry point of view. Okay, so similarly in organic chemistry, as the oxidation suggests, the gain of oxygen So the reduction will be the vice versa. That means the reduction suggests the loss of oxygen or gain of hydrogen is often referred as reduction. Okay. And alternatively, reduction is referred to as the conversion of one functional group lower in the sequence of another higher functional group. Now let us understand with this simple yet important example. Now here you can see this is our aldehyde. Okay. Now if we go this pathway, so it will generate an acid. That means this particular carbon is getting one oxygen. That means this particular aldehyde moiety will gain one oxygen. That means it will be oxidation. Similarly, if we go this way or backward pathway, like this particular oxygen is there, but here it is present in the double bond. Now here this particular oxygen present in the single bond. And also there is only one hydrogen is there, but now here is a two hydrogen is there. That means this particular aldehyde, while going via this backward pathway, will gain one particular hydrogen. That means this is the reduction takes place. Now we can talk about the oxidation numbers. Like here in this particular carbon, if we calculate the oxidation number, this is +1. Now, how to calculate oxidation number, we'll learn in this particular lecture, but a little later. Okay. And here in the case of carboxylic acid part, the oxidation number of this particular carbon, this is center carbon, is +3. Similarly, here this oxidation number of this particular center carbon is -1. So here you can see the trend. Find that in the case of aldehyde, the oxidation number of this particular carbon is +1. Similarly, if we go via backward, in the case of alcohol, the oxidation number is -1. And in the case of carboxylic acid, the oxidation number is +3. Now you can understand this important phenomena here. Now this particular aldehyde, while going this particular pathway, okay, will gain 2 electron. Okay. Now while it will gain 2 electron, then its oxidation number goes +1 to -1. Okay. And similarly, while moving this particular way, like alcohol to aldehyde, it will lose 2 electron. Okay, so that means it is initially -1, then it is lose 2 electron. That means the increase in oxidation number to get the +1. Okay. Similarly, if we see here that in this particular aldehyde, it is +1 to +3. That means number of increase in oxidation state is +2. That means this particular aldehyde will lose 2 electron, okay, to getting this particular structure. That means it is oxidation takes place. Similarly, if we go via backward from carboxylic acid to aldehyde, there will be a number oxidation number changes 2, but here carboxylic acid gain 2 electron, and due to the gaining of 2 electron, the oxidation number of +3 is now reduced to +1. That means we are actually proof the basic condition of oxidation and reduction. Like oxidation is the mean loss of electron and the reduction means gain of electron. I hope this will be clear for you. Now we are talking about a very interesting thing, that is the how to determine the oxidation state. Now first we have to understand that what is the oxidation number or oxidation state. The oxidation number or oxidation state of an atom is the charge that would exist on the atom if the bonding was completely ionic. Like here we are discuss about the oxidation number. Like if this particular bonds are completely ionic, then we can say that this particular carbon having the +3 oxidation number. Okay. And this will be very much important in terms of reagent chemistry pattern. Not only reagent chemistry, like in case of any kind of organic transformation, or we can precisely say that in case of redox transformation, the determination of oxidation state is very, very important. Okay. Now, how to determine the oxidation number of any organic compound? Okay, there is certain rules are there. Like the first rule suggests, the oxidation state of uncombined element is zero. That means when you are seeing the Cl2, Br2, H2, this type of compound are actually uncombined. So the oxidation number is zero. Okay. The second rule suggests that the sum of the oxidation state of the all the atom or ion in neutral compound is zero, and sum of oxidation state of all the atoms of ion in the ionic compound is equal to the charge of the ion. This will be very, very important. And the third rule that is also very hold very significant in the determination of oxidation state, that is, between a bond, the most electronegative atom is often assigned a negative oxidation state, and the less electronegative atom is assigned to a positive oxidation state. And if the particular compound having the same atom which having the same electron possess the same electron negativity, then this type of atoms have no effect to determine oxidation state. We'll explain it in the example part in the next part. Okay. So before that, we have to understand that another thing, that some of the element, when we are calculating oxidation state of a particular organic compound, we have to remember that some of the elements has shown the same oxidation state in their compounds. Like when the particular organic compound having any kind of group 1 element, then it will show always +1 oxidation state. Similarly, when the compound is in a group 2 element, they will show always +2 oxidation state. Now in the case of oxygen, like if your organic compound contains oxygen, it shows usually -2, not +2, usually show -2. But in the case of peroxide, superoxide and F2O, it will show different oxidation states. Now if your compound have hydrogen, then it will usually show +1, but in the case of metal hydrides, it will show -1 oxidation state. Fluorine is the highest electronegative atom, so it will always shows -1 oxidation state. Chlorine is usually -1 shown, but when it will combine with the compound with oxygen and fluorine, which is the higher electronegative than fluorine, then it will show variable oxidation states. Okay, so now we do some kind of practical approach to understand or determine the oxidation state of certain compound. So here let us do some hands-on example to determine the oxidation state of the following compound. This is the mark sheet. So first we are talking about this. So this is CH3 COOH. So we have to determine the oxidation state of this particular center. So let us assume that the oxidation state is X of this particular carbon. Okay. So now we have to determine, see, this also carbon, this also carbon. So that means this particular carbon will doesn't show any effect to determine the oxidation state of this particular center. So the oxidation center of this particular carbon will solely determined by this particular oxygen and the OH group. Okay. So this oxygen will contribute -2. Okay. This particular oxygen will contribute -2, but since one hydrogen is attached with this particular oxygen in direct fashion, so due to electronegativity difference, this particular hydrogen will also show the +1. And from our rules of determining oxidation state, we know that since it is a neutral compound, that means the sum of the oxidation state is equal to 0, since it is a neutral. So let us determine, like for the carbon it is X, for this particular oxygen it will -2, this oxygen will contribute also -2, and this particular hydrogen will contribute +1, equal to 0 as per the rules. So that means the X will be +3. So the oxidation state of this particular carbon in carboxylic acid is +3. Similarly, let us understand to determine the oxidation state of this ketone. Uh, this will be easy. Okay. So what happened that these two particular carbon, this also carbon, so they are similar atom. Although you might get confusion that why this particular hydrogen not even considered, this hydrogen even considered if this is not carbon, this is nitrogen. Okay, because then this bond have a electronegativity difference due to this particular different atoms having different electronegativity. Since these both are carbon, so these carbons are not actually participate to or influence this particular influence or participate in this particular determining the oxidation state of this particular carbon. Okay, so this particular oxygen center will contribute -2, and we are assume that this have X. So since it is a neutral compound, so the count will be 0. So X -2 equal to 0, or X equal to +2 here. So this particular ketone, the oxidation state is +2. Now let's talk about the methanol. OH, H, H, and H. Okay, so here you can see that all the particular carbon atom having the direct bond with different electronegative atoms. So all are actually counted. So as our previous discussion, let us assume that the oxidation state of this particular carbon is X. So all of the hydrogen is contribute +1, +1. This particular oxygen will contribute -2, and since this particular oxygen is directly contact with the hydrogen, so this hydrogen will contribute +1. So X +1 +1 +1 -2 +1 equal to 0, since it is a neutral compound. So the count will be 0. So we just simply calculate here, and we observe that the X will be -2 for the case of methanol. So say that all the time the carbon oxidation state will not be in plus, sometime it will go for a minus also. Now we are talking about this particular ethanol. Methanol is done. Now we are talking about ethanol. So I am just rubbing out this particular carboxylic acid and do the ethanol. So it contains 2 hydrogen, 1 OH, and 1 methyl. Now since it is a carbon-carbon bond, so it will not contribute. So we can easily omit this particular thing, or we can assume that it is 0. Okay, and this will provide +1. This also contribute +1. This -2, and since the oxygen is there, so it will contribute +1. So since this is also a neutral molecule, that means and this is assume X. So X +1 +1 -2 +1 equal to 0, or X will be -1. X will be -1. So with like this, you have to determine the oxidation state of the following compounds. So there is a little homework for you, like determine the oxidation state of these two particular. It is already, you know, the answer in our third or fourth slide. It will be clearly written that the oxidation state of this particular carbon, but you will determine the formaldehyde and put the answer in the comment section. I will, uh, whoever goes correct, I will give a heart or pin the particular comment. Okay. So with this, we have to end this particular lecture. So in our next lecture, we're talking about the selectivity of organic reaction, mainly regioselectivity, chemoselectivity. So stay tuned for that. And till then, go back to our previous class, make proper notes, and revise whatever I have learned. We have learned today. Okay. So we'll meet on next class.